Hey everybody, it's Mr. Mott. What we're going to do is we're going to be melting some ice. Fascinating science going on when we melt ice. Okay, so we're going to be using a program called Logger Pro, and we're going to show you what it looks like graphically and what it looks like in real life. All right, so here we go. So what I've got is I've got a beaker with some crushed ice in there. If you're doing this in the lab, you want to make sure you use crushed ice. Cubes, there's too much space in between there. You're not going to get good data. All right, we're going to go to set this on our hot plate there, and you can see that on the graph that it's reading at the temperature is reading at about 0.2. All right, we got a little sizzle going on the hot plate because I had this on before. I'm going to go ahead and turn it up right now so we can start melting our ice. Okay. All right. If you're doing this in lab, a couple good technique ideas is you want to make sure that the temperature probe is not touching any part of the beaker, and then also you want to make sure the temperature probe is surrounded by ice. And you can use something else like I'm using a wooden splint or something else to kind of stir the ice and move it around as it's heating up. Okay, so hopefully what we're noticing here down here at the bottom is that this ice is already starting to melt as we add the heat. Now what's fascinating is that during this time you'll notice the temperature is pretty much remaining constant. Okay, certainly within the error that's involved in terms of the actual temperature probe. Okay, so we're adding heat and what we're noticing is the temperature is remaining constant. Okay, so right, and that should be the case until we melt all of our solid and our solid turns completely into a liquid. Okay. Now thinking about what heat energy is, and is able to do some work. Well, what's the work doing? Well, the work is changing the position of the particles. So, so in a solid, we know that the particles are very tightly packed, very rigidly organized, and the particles can't really move around very much. They kind of can vibrate in space, if you will. But in liquids, the molecules, while still in contact, can kind of move around each other. And so when we think about what's happening, the particles are moving from, the heat causes the particle move from a very rigidly packed formation to a very more loosely arranged where it can kind of move around. All right, and so that's kind of what we can see in our graph, and we're getting slight fluctuations there. I think I'm not keeping the temperature probe in, surrounded sort of by all the ice and kind of keeping it, mixed up in here. When we do that, I think we're going to see that, yeah, it's right around 0 again as we continue to stir. All right, so I'm probably going to stop it here in a second because we're kind of got the point of the idea is that if we keep everything mixed here, when we're going from a solid to a liquid, when we're in that phase change, the temperature remains constant. And I think that's what we're seeing on our graph. All right. Once all of our solid turns into a liquid, okay, which we're very close to doing, once that happens, okay, we still have some ice in there. Once that happens, that's when we're going to see the temperature go up. All right, so I'll continue to heat it a little bit longer and see if we can get that to happen. Just kind of burn myself. All right. Ooh. As you can see, it takes a lot of energy and a lot of time to be able to heat up and melt this ice, cause all the positions of the particles to change. And so you can see we'll still have a little bit of ice in there, and we are nearly there. Okay, Just a little bit more ice that's in there. All right, almost all that ice is gone. So now pretty much all of our ice is gone, maybe just a little bit left in there. And so now we're going to see the temperature rise as because now the heat that we're adding is going towards raising the temperature of our liquid. All right. So that's what we wanted to learn about heat and temperature during a phase change. So when a phase change is occurring, the temperature remains constant because the heat that we're adding goes to changing the position of the particles and not increasing the temperature. Thanks for watching.